Hello again, everyone. This is special English version of the Soviet Tanks Armor series for my friend Matt. Matt, I hope you gonna like them. And today a very interesting topic, because we will talk about the first mass-produced, although not the first in the world, tank with composite or special armor, if you prefer. We will talk about the T-64, T-64A and T-64B. It was from these machines that the T-72 and T-80 tanks later evolved. But it was the T-64 in many aspects, and through the 1970s until the 1980s, that was the most progressive Soviet MBT. Of course, I will focus on the armor here, because the whole story is so extensive that it is more suitable for a book, and a quite thick one, than such a short presentation. So let's get started. In the 1950s, all over the world, it was realized that the most dangerous type of anti-tank ammunition would be a shaped charge warhead. This was due to the very high armor penetration capabilities of such type of ammunitions for those times. A classic homogeneous steel armor that could protect against them would have to be extremely thick and at the same time extremely heavy. In addition, the advancement in the field of shaped charge warheads was so rapid that such armor would become obsolete in a fairly short time. Various research and development projects have been undertaken around the world to find a solution that can counter this threat. In the United States, work was carried out on silicious cord armor, or SCA armor in short, where fused silica was used between the steel layers. In United Kingdom, work was carried out on various types of spaced armor arrays, fuel tanks acting as armor, and other inventions. Germany and France decided to sacrifice tank armor in favor of higher mobility altogether. Work also was performed in the Soviet Union, where a similar direction of research and development was chosen as in the United States. The work was carried out at the then known Institute of Physical Engineering, currently known as the Abram Fyodorovich Yoffe Institute of Physics and Technology, as well as the VNII 100 Research and Development Center under the supervision of engineer Vasily Starovoytov. Let's start with Object 432, the original T-64. We will start with the description of the whole armor, initially in the technical project from 1961. A two-layer system was proposed, consisting of a steel plate with a thickness of 80 millimeters, behind which there was a layer of glass textolite with a thickness of 140 millimeters. it soon turned out that such a system did not fully meet the requirements, and it was slightly modified. So here we can see the original T-64 project with a two-layer type of front hull armor. In the modified project of the front armor, the glass Texlite layer was reduced to 105 millimeters. It was made from two 52 millimeter plates of glass Texlite, and then was followed by a 20 millimeter thick armor plate. The whole armor array is inclined at an angle of 68 degrees. This arrangement was adopted for the T-64, T-64A, T-64B, the T-72 Ural and TAD tanks. For the turret, however, two special armor systems were proposed. The first proposed armor system variant was a cast turret shell with ceramic blocks embedded in it during the casting process. From the front, the maximum thickness of this armor was about 420 millimeters. The second variant assumed the production of a cast turret shell with chambers for the special armor layer. When main turret shell cooled down after casting, molten armored aluminum alloy was poured into this chamber, which after solidification formed the special armor core. From the front, the turret with this type of armor had a maximum thickness of about 500 to 600 millimeters. During the production of the T-64 tank, this second variant was chosen, probably because it was cheaper and easier to manufacture. This turret, however, had some disadvantages. First of all, the weight of the turret increased compared to the first proposed variant. Secondly, in certain turret positions, the driver's hatch was blocked by its massive frontal armor. It was therefore not a satisfactory solution. So as you can see here, these are technical drawings for the turret armor, and here is the drawing showing how the armor interacts with shaped charge projectiles. Therefore, steps have been taken to solve this problem by developing the turret with new special armor. Let me quote here an excerpt from a book describing the official history of the Ni Stali Institute. And so I quote, "The task was to eliminate this drawback without increasing the distance between the axis of the rotation of the turret and the axis of the hatch opening. For this purpose, the thickness of the turret had to be reduced compared to the aluminum steel turret by almost 200 millimeters, from 600 to 410 millimeters. The decision to change the thickness of the turret while maintaining its anti-shaped charge and ballistic resistance within the specific requirements was proposed by engineer Jerozolimski. He proposed to do so by using high-hardness steel inserts for the turret front, heat-treated by differential isothermal quenching to obtain a particularly hard core and a relatively less hard but more plastic outer surface. The stability score was quite decent, better than on the VNII Transmash ceramic ball experimental turrets, which had a greater overall thickness compared to high hardness steel fillet towers. The disadvantage of the turret with high hardness steel inserts was the low resistance of the welds between the plate closing the special armor chamber and the turret shell, which was destroyed without penetration after an armor-piercing projectile hit it. In connection with the obtained results, it was decided to start the production of a batch of turrets with high-hardness inserts with preliminary measures to strengthen the welded joints. But here something unexpected happens. In the produced batch of hard plates, it was not possible to provide the minimum required strength, and the hard plates turned out to be brittle and cracked when fired upon. On this photograph you have a T-64A tank with that kind of turret with the high hardness steel plates. And this is how the high hardness steel inserts looked like in the turret. Therefore, the solution turned out to be not entirely successful, and probably it was not introduced on the new machines, designated as Object 434 or T-64A on a larger scale. Although we can assume that perhaps a small series of these tanks received such armor in the form of a trial batch. The search for another solution had begun. Such a solution was to be a return to the idea of ceramic protection embedded in the steel shell of the turret. This time, however, instead of ceramic blocks, ceramic balls were to be used. Such ceramic ball is visible on the photograph. On the basis of the decision, 12 GU MOP of the military unit 52682-3 in 1966, the heavy machinery construction plant in Zhdanov was able to cast the first 50 towers with ceramic fillers in form of ceramic balls. In September and November 1967, the military units G-4448 and 68054 carried out ballistic tests of the armor of 3 turrets of this new type with special armor in the form of ceramic spheres, or balls if you wish. The turrets were compared with turrets with special armor made of high hardness steel plates. As many as 105 test shots were fired, and based on the research, a letter was sent to the chief engineer in the KB-60M design office responsible for the T-64 tank, Alexander Alexandrovich Morozov. And I am quoting. In September and November 1967, in the G-4448 unit and the 68054 unit, 3 turrets with special armor in the form of ceramic spheres were tested by firing, made in various mass variants with turrets with high strength steel inserts, During testing of these towers, 105 shots were fired. Of them, A. Cumulative or shaped charge ammunition at standard muzzle velocity, 38 shots. B. Same type of ammunition but with increased muzzle velocity, 18 shots. C. Sub-caliber ammunition fired from the 115mm 2A20 Molot cannon, 9 shots. D. 100mm armor-piercing shell, 15 shots. This ammunition never penetrated the turret armor. The test results show that turrets with ceramic spheres core have achieved a margin of anti-shaped charge resistance compared to those specified in requirements, and therefore there is a real possibility of some weight reduction of these turrets. Taking into account the results of the preliminary work with modified forms of ceramic filler, further weight reduction of the turrets should be expected. In addition, as the manufacturing experience has shown, the turrets with ceramic spheres have better productivity, less labor requirements, shorter production cycle compared to the other turret options, as evidenced by the letter from the G-4448 unit, see letter number 00252, which in particular indicates that the complexity of the workmanship of the Object 434 turrets with ceramic filler are less than approximately 900 standard operating hours compared to the turrets with high hardness steel plate inserts. It should also be noted the use of a cheaper non-strategic raw material as turret filler in form of ceramics. So this is how the ceramic spheres were inserted into the turret casting. These spheres or balls created the armor belts, which will be mentioned later on. A number of the above essential properties of ceramic filled turrets give us the basis to support the recommendation for further work on finalizing the design of such turrets and for the final series production testing as described earlier in letter number 7889 of December 22, 1967. In connection with the current preparation of our factory for the production of the Object 434 tanks, as well as the preparation of their production in other tank production plants, we consider it necessary now to decide about the type of turrets for mass production of the Object 434 tanks. Considering the above advantages of ceramic filled turrets, we believe that we will prepare for the production of these towers or turrets at the G-4448 plant in parallel with their final development and testing. Before starting serial production, one turret should be precast in order to develop the final geometry in accordance with the design and tested by ballistic tests in G-4848 plant no later than May 15, 1968. If the results of the turret tests are positive and it is possible to improve it, we will start serial production of the turrets, and 2 turrets from the first batch should be put through control tests by the G-68054 military unit or in the G-4448 military unit under the direction of the G-68054 military unit. Necessary improvements on the results of these tests should be introduced in the mass production process. So here we have the fragment of the turret armor after ballistic tests. As we can see, the armor stopped and contained the projectile. And here is the drawing showing the design of the turret and placement of the ceramic spheres inside it. And here is the model photo. It seemed that the problem of the tank's turret armor had been resolved, but it turned out that the developers of the rival turret with special armor in the form of high hardness armor plates questioned the results of the turret tests with ceramic armor. I am quoting: "As a result of research and development works carried out by the Unit A-7701 VNII Transmash in 1967, 3 experimental turrets with ceramic fillers K22, K23 and K24 were tested. Based on the test results, the A-3530 plant in letter number 7852 SS of December 22, 1967, in 1968, proposed the production of a batch of turrets with ceramic filling for the Object 434 tank, this means 5 units, and for the tank T-64 Object 432 in 50 units number. On this application, we consider it necessary to present the following conclusions. Number 1. None of the tested turrets, K22, K23 and K24, were within the mass specified by the chief designer. The internal volume has not been adequately sized in the turrets. These data are not included in the report number 005105 regarding the testing of the K22, K23 and K24 turrets at Unit G-4448. The available data on the marking of the K23 turret tested in the military Unit 68054 showed that the turrets were manufactured with a weight 200 kilograms higher than required. According to our measurements, the overall cubature of the K22, K23 and K24 turrets exceeds the assumed dimensions by 10 to 20 millimeters. All this does not allow us to assess the level of protective properties and survivability of turrets with ceramic filler, subject to the specific weight and overall dimensions of the turrets. Number 2. Despite the advantage of the ceramic filled turret, their survival rate cannot be considered as satisfactory. For example, the penetration of a 100 mm anti-tank shell in the lower part of the K24 turret near the belts 1 and 2, shot number 17, created a gap along the lower end, 370 mm deep, with a cast steel shift of 30 to 40 mm along the fracture. Such a hit completely disables the turret. No such damage was observed in the turrets with aluminum filler and high-strength steel inserts. In the K22 and K23 turrets, manufacturing defects were noticed on the outer shell layer. For example, on the K23 turret, when an armor-piercing shell of 100 mm caliber hit the turret, a fragment of the armor measuring 300 by 300 by 120 millimeters broke off the turret. Such damage was not observed even on the turrets with aluminum filler. During testing at the test site in Pavlograd, turret number K16 and K17 was hit with a 100 mm subcaliber projectile with a tungsten carbide core fired from the D10T cannon. A very low resistance was obtained. report number 28 of 25/12-67 with 7 hits in all areas of the turret with velocity between 1400 to 1450 meters per second at an angle of inclination of plus minus 35 degrees. 7 penetrations with an initial diameter of 70 to 80 mm were obtained. Penetrations were also achieved in those areas of the turret where the weight of the armor with ceramics in the cross-sectional directions was equal to the armor thickness of the K23, K24 turrets. Our tests of armor samples have shown that protection against the indicated type of projectiles at velocity between 1400 to 1450 meters per second is provided by towers with aluminum filler, glass fiber, and inserts made of high strength steel, with thicknesses as used on the hulls and T-64 tank turrets and Object 434. The new domestic armor-piercing shells for 100mm and 122mm caliber guns with a tungsten carbide core are the same as the 105mm APDS shells of the main NATO tanks, the M60A1 and Leopard 1. And in our opinion, the protection of T-64 and T-64A against 105mm tungsten core shells is required at distance of up to 1000 meters, specified by the requirements for T-64 and T-64A tanks to protect against subcaliber shells. According to our calculations and other data, at a distance of 1000 meters at velocity equal to 1360 meters per second, the English APDS ammunition penetrates up to 350 millimeters of medium hardness rolled steel armor, plated at 0 to 35 degrees and slightly exceeds the capabilities of 100mm and 122mm cannons of domestic manufacturers in terms of the capability to penetrate armor at this muzzle velocity. Based on the above, Unit V-2652 believes that the proposal to produce 55 turrets with ceramic filler for the T-64 and T-64A tanks presented by the Malyshev plant and the A-3530 plant are premature because it is not supported by the required number of suitably positive test results for such turrets or armor samples. In our opinion, currently for a turret with ceramic filler, it is necessary: 1. Determine their compliance with the specified protection requirements with full compliance of the turrets with the specified general parameters, height, dimensions, weight, given in the drawings. Number 2, it is necessary to determine the ballistic protection level of ceramic filled turrets when they are hit by a tungsten carbide core subcaliber projectiles, because when testing the K-16 and K-17 turrets, the protection level against these projectiles was very low. Number 3, it is necessary to carry out works aimed at improving the survivability of turrets with ceramic filler during firing from 100mm caliber cannons in the lower zone of the belts 1 and 2. Therefore, the proposal to produce 55 ceramic filled turrets can be considered by successfully resolving these issues. And sorry for the translation, this is from translated from the Russian, so translation is kinda sketchy. So here we have another drawing showing the T-64A variant with the turret having the high hardness steel inserts. Here we have a photo of the T-64B. And so, in the end, the turrets were improved. But it also turned out that the above list was exaggerated, which resulted not only in increased R&D costs, but also delays in the production of tanks. Finally, at the end of the 1960s, the production of the T-64A tanks with a turret equipped with a special armor made of ceramic spheres/balls was started. This armor did not change during the production of the T-64A and T-64B tanks. However, there is information that during production there were still problems with maintaining the quality and uniform parameters of the armor protection. On the other hand, the frontal hull armor underwent changes during the production and modernization of tanks, which can be seen on this picture. So, it is interesting to note that the production series T-64BV had a different type of front hull armor. It is seen on the bottom of the drawing, compared to the T-64B tanks upgraded to the T-64BV standard. So the second drawing from the bottom is the T-64B upgraded to the T-64BV standard. In 1985, the modernization of the T-64B tanks to the T-64BV standard was started, as well as the production of the new build T-64BV tanks with a changed front hull armor layout, and the protection was also strengthened by installing the Contact 1 explosive reactive armor modules. Of course, the entire story is more complex, and unfortunately for English speakers or people that do not speak and read Russian, the best sources are obviously in Russian or Ukrainian. But I hope that this video kinda explained the evolution of the T-64 armor protection and the problems connected to the development of the armor for this type of tank. And I hope, Matt, you liked it. Other videos for the T-72 series and T-80 series I will prepare later. So I will catch you guys all in the next videos.